factors affecting climate change. That's what we're getting into right now. Does anybody know, and we talked about this before, which 4 things am I going to bring up here? Now you have the notes, so you'll probably be able to tell. But we talked about this at the start of the class early on when we met. There were 4 things that are important for everywhere around the world and how their climate is there. So vocabulary wise, climate is the expected thing that we're going to get, okay? Climate is the expectation, weather is what we get. That's basically how it is, okay? Because climate is patterns of the weather that happens in a certain place. So for Winnipeg, we get cold winters and we get hot summers, and then we get kind of rainy in between, all right? That's the usual way it happens. Around the equator, it's hot and stinky all year. Sometimes it rains, sometimes it's super dry. It depends on where you are and the influences that we're going to bring up today. So the 4 things that we have that would influence climate everywhere on the planet, or let's say would be a lack of influence. For example, Winnipeg is not affected by oceans. We have the lack of that effect, right? We are flat and very far away from oceans, so we don't have that influence. Therefore, we have a different kind of climate. That's very different than Vancouver, BC, which is right on the coast. Same latitude, very different seasons, very different temperatures, very different rainfall patterns, precipitation, etc. Okay? So the 4 things that will affect or not affect everywhere on the planet would be the biggest one, latitude. Okay, how far are you away from the equator? Are you right on it? Because you're going to get hot all year. Nothing's going to change. Sunlight will stay around. When I lived on the equator for 2 years, the sun came up at 7:30 and the sun went to bed at 7:30 every single day of the year. It was 30 degrees every single day of the year, and it always rained at 4 o'clock when I was trying to walk home from school. It's really great. So latitude would be the biggest effect, because you would get the further away from the equator would be more fluctuations in temperatures, sunlight, and there we go. We're 49 degrees north, 49 degrees away from the equator, and therefore look at what we get. Very cold winters, very hot summers. So a lot of variety in between, right? So basically the amount of sun you get makes a big difference. We get trace amounts specifically when it's cold outside, based on what we talked about in one of the previous videos, solstice and equinoxes and how the rays hit and the tilt and things like that. You know, the equator, the tropics are getting direct sunlight all year. That's why they're hot. We're not. We only get the direct ones when we're tilted towards, you know, starting kind of right now when it's starting to get warm. Check out how the days are getting longer and what's it doing to the temperatures. Okay, is there a connection? Absolutely. Another one is, and this would be a big one for Winnipeg, pressure systems. We rely on what blows into our neighborhood. Okay, nothing's stopping the wind. It's windy here all the time. And look at the last week or so. This is Thursday right before the long weekend, April 9th. Look at the last week of weather that we've had. It really depends on which way the wind is blowing. When it blows from the north, weird, it gets cold. When it blows from the south, weird, we get 10 degrees and sunny. That's kind of what it does. So we'll talk about things like convection cells and what they do, because there is a grid system around the world. There are patterns of pressure systems, and generally in Canada, we get what Saskatchewan gets. Wind comes from the west, and that has a big deal to do with where the sun rises and sets. Things get warmer in the east first, and it drags the warmth with it as we rotate constantly in the same direction, right? So are you close to the ocean or not? That makes a big deal as well. Places around the coast will get more rain, and they will have less temperature range. That's a big term for describing these two. Continental places like Winnipeg, Manitoba, would experience a massive temperature range because we don't have the influence of the ocean. Okay, and I'll explain that more when we get to that. Okay, so places around the ocean, your temperature range is smaller, the difference between the highest and lowest temperatures. Okay, and that's the ocean that does that. We'll bring up things like ocean currents and how they spread things. There's cool ones, there's warm ones, and they make a big difference wherever they slam into the coast. Last one, not as broad as the other three, but if you live in altitude, you're going to experience different things. The higher you go, the colder it gets, basically. That's as simple as it is. Here in Winnipeg, we definitely don't struggle with altitude, okay? So basically, those are the four. We're going to go through each separately, all right? So we'll start with latitude, or no, I'm not going to do them in order. I'm going to start with the easy one first, I guess, or latitude. Maybe I'm going in order. I forgot. Latitude. So, again, underline in bold, this is what I'd like you to soak in. There will be things to do with some of this. And again, you have these videos. You can watch them 15 times in a day. Why would you want to do that? Up to you, okay? So you can have this class over and over and over again if you'd like. Basically, as I said, the closer you get to the equator, the warmer it gets. That is because the sunlight is, again, more direct than it is where we are. Because we live on a ball, you can't shine everywhere at the same time. I like to think of the world like a rotisserie. You know what a rotisserie is? If you have a piece of chicken that's constantly turning over the heat in this case would be the sun, and the chicken in this case would be the world. Well, that's why it's turning, rotating. Only certain parts of it can heat up at once, okay? It's not daylight everywhere around the planet at the same time. It's slowly moving, right? So that heat is as well. Okay? Don't worry about that stuff. But basically, I'm going to toss out some Sun-Earth relationships here. Basically, as latitude increases, so gets bigger from the equator, which would be 0, remember? So as we go further north or further south, the temperature range generally increases as well. And again, that's the difference between the highest and lowest temperatures. So if we look at a map of the world, whoa, you can notice where there's ice, and you can notice where there's deserts. This is kind of the same map that I have on my corner over there that I've been referencing all year so far. This is where it's hot, so this is where the equator is right here. These would be the tropics, okay? And between right here, that's where all the heat is. Some places are dry, some places are wet, okay? There's a lot of connections you can make with latitude. All the deserts on the planet are on the same latitude, between 10 and 30 degrees north or south, okay? Here's 10 and 30 degrees north or south. And here's 10 and 30 degrees north or south. So it's consistent. All three major rainforests on the planet are basically at the same latitude as well, and that's kind of right here. Here's the equator, okay? Green, green, green. A lot of connections there, okay? We'll get back to the other tude, okay, altitude. And basically, this picture here is from a beautiful mountain scene. Okay, you can see snow on the tops and pretty little flowers. It's a great picture to use. I don't need to say anything else. How can there be snow and flowers at the same time? Okay, it doesn't make sense. So, what we have to understand is that, I don't know if you can tell from the picture, but around here, there's a point where snow stays, and underneath it, snow doesn't. So as you go up, and it's about a degree every 100 meters in altitude that you lose. And that's why in very hot places, I was always amazed at Mount Kilimanjaro having glaciers on it when it's right on the equator. So based on latitude, that doesn't make sense. But based on altitude, it sure does, right? So altitude, basically, the higher you go, the cooler it gets, all right? And again, the rate is about a degree every 100 meters, okay? Pressure systems, these are responsible for wind, Okay, so it's a very simple thing. I'm sure all of you at one point in your life have blown up a balloon. Okay, if you want to try it for the first time, go get it. Okay, blow a big balloon and then don't tie it around, just let it go. I would imagine you're smart enough to figure out what would happen if I blew up a balloon and let it go. All the way around the room, right? So that is you putting air, you putting air under pressure in the balloon, and when you let it go, it wants to escape to a lower pressure. That is the rule, okay? This thing in the white that you can't see says H to L, high to low pressure. That's the way the wind will blow. So what do we need to know to understand this is how do we create a high or a low pressure? Because if we know which way the wind is blowing, we can probably understand where the low and where the high is. So it's exactly like a balloon, okay? And we create these voids. So as we go into more in depth in terms of pressures, there's these pressure belts all around the world. So there's what's called prevailing winds comes into play, where there's kind of predictable winds going in certain directions all year long. So animals who migrate in the air follow prevailing winds, because this is me flying, because it's easier. Pilots follow prevailing winds because you use less gas and you get there faster. Makes sense, right? To create a low pressure versus high pressure, one's usually the result of heating and one's usually the result of cooling. Now, in everything with geography and science, there's generalities, so I'm going to say usually because that's usually the case. Whenever there's a little bit of heat, okay, that will create some, heat rises, remember, that's a very important rule for climate, and cool things sink, which is another important rule. So as we're getting this, that's kind of, when air rises, it creates a void. So something needs to fill it in, right? So if we have a low pressure system coming in like a Colorado low, we're getting warm, moist air coming from the States and dumping a whole bunch of snow. When we get cool air coming, when we're a little bit warmer, we get cool air coming from the north, which is, again, stay inside, light a fire, hope for the best, okay? So this is the last thing I'll leave you with here. And a more local thing. So those of you that have access to water, like if you go to the lake or if you go to Grand Beach or if you've ever been to the ocean, whatever. If I were to ask you what heats faster, land or water, think about it before you answer, because I can't hear you anyways. But think of an ice cube tray. You toss it in the freezer. It's not like, oh, I got ice, okay? It takes a while for it to freeze. And then if I were to take an ice cube out of the tray and leave it on the counter, it would take a while for it to thaw, okay? So land and water, this is a huge thing for maritime versus continental. Water moderates things. It keeps things warmer when it's cold, and it keeps things cooler when it's hot, okay? So in terms of this, water would heat a lot slower than land. So when the sun goes down, if you've ever been swimming at night, you may think, oh boy, the water's a lot warmer than it was earlier in the day. That's just because relative to temperature, it was hotter in the day, so the water seemed colder. Now it's colder outside, water seems warmer. Okay, it's about the same. All right, so think about over 24 hours, when things would warm and when things would cool. Obviously, it's generally warmer in the day and cooler at night. Okay, so this is an example of sea breeze, local thing, and I experience this all the time every summer when I go to the lake. Day versus night, which way is the wind blowing? So if you were the lake and I was standing here looking at my beautiful lake, which way would the wind be blowing? Okay, right at me, off the water, because of these pressure systems. Okay, the land heats faster, create that low pressure system, air rises, something needs to fill it in, brings wind off the lake or ocean, wherever. Okay? When the sun goes away, what stays warm longer? The water. Low pressure system, something needs to fill it in, you get wind blowing off the land. And that is huge in terms of when we talk about a bigger picture, when ocean currents are involved, and places like Vancouver, Victoria, Seattle, London, England, anywhere along the coast, that's kind of, the water moderates things and changes the way these breezes blow. Okay? So when is it the windiest? Generally during the day, when the sun's out, when the pressure systems are mixing and mingling a little bit more. Okay? Convection cells, these would be kind of these pressure belts that would create things like prevailing winds. Okay? So again, the rotisserie, because we live on a ball, not everywhere gets the same amount of heat either, even when it's facing the same direction. So if you look at this map, which you can't really, I've separated into basically these belts, high, low, and alternating. When you look at it online, you'll see that the arrows represent the prevailing winds, and they're blowing high to low, and they're kind of, it's called the Coriolis effect, where they're kind of curved because of the rotation and us living on a ball. Okay? See you next time.